Yeah, good morning. I am Afolabi Said Omatunde, Director Access Point.
Good day, viewers. Yet again is Access Point Academy video lecture series, and in our class today, we shall discuss the concept that has to do with atomic number and mass number. Okay, so the first question is, what is atomic number? It has the symbol AR. So atomic number is the number of proton. Like we all know that the nucleus of an atom has proton, neutron, okay, and the atom entirely has proton, neutron, and electron. So the number of proton is known as the atomic number. So atomic number is the number of proton, as simple as that. Now also, elements in the periodic table are arranged in order of atomic number, in order of proton number. Okay, so atomic number and proton number are the same. For instance, hydrogen has an atomic number of 1. So therefore, the proton number of hydrogen is 1. So the fact that hydrogen has atomic number of 1, therefore the proton number of hydrogen is 1. The same as sodium. Sodium has an atomic number of 11. Therefore, the proton number of sodium will be 11. Okay, so because it has atomic number of 11, then the proton number will also be 11. The next is another element is uranium. Uranium has an atomic number of 92. Therefore, the proton number of uranium is 92. So they want us to note that in an atom that is in an atom that is neutral, atomic number is the same as the proton number, which is the same as the electron number. In an atom that is neutral, proton number and electron number are the same, which are equal to atomic number. So you need to note that as a student of physics and chemistry, science student generally. So now, next is, what is mass number? So they want to teach us what is meant by mass number. So now mass number is the sum, okay, of proton and neutron. Okay, so the mass of an atom is actually generally concentrated in the nucleus, and in the nucleus of an atom you have proton and neutron. All right, so now mass number is the sum of the proton number and the neutron number. That is, by sum we mean addition of the proton and the neutron number. We give the mass number. Why? Because the mass of an atom is concentrated at the center of the atom. Now, they want us to know that the total number of particles in the nucleus of an atom is the what? The mass number. So in the nucleus of an atom, we have proton and neutron. So the total number of particles in the nucleus of an atom is the mass number. Okay, so they ask you to calculate the mass of an atom, so you have to add all the protons and the neutrons that are present in the atom. Now, so we can simply write that using an equation. So mass number is equal to proton number and plus neutron number. That is the mass number. And in a situation where you are asked to calculate the neutron number, for instance, excuse me, so if you are asked to calculate the neutron number, you just have to make neutron number the subject of formula, and neutron number is going to be mass number minus proton number, because proton is going to go to the other side of the equation. So you have mass number minus proton number. So that explains that. Okay, for instance, look at the element sodium. For instance, sodium has the symbol of Na from the Greek natrium. Okay, so the atomic number for sodium is 11. Okay, which is also the same as the proton number, or the number of proton, which is also 11. However, the neutron number for sodium is 12, and the electron number, don't forget, the electron number is the same as the proton number in a neutral atom, so which is also 11. Now, how do we now get, therefore, the mass of sodium, the mass number? Okay, therefore, the mass number of sodium, Na, will be the sum of the proton number. The proton number is 11 plus the neutron number, which is 12. So when you add the two, so that is going to be 23. Okay, so 23 is the mass number of sodium atom. Okay, so that is how together. So the neutron number is 12, the proton number is 11. Now, we quickly look at nuclear notation. How do we represent an atom, the nucleus of an atom? Nuclear notation. Now, the mass number and atomic number of an atom as shown by writing them with atomic symbols. Okay, atomic symbol. How do you represent atom in science, in chemistry precisely? So the atomic symbol is called the nuclear notation. So illustration. Now let's assume X is an atom of an element. So X is an element. Okay, so now at the bottom left side here, that is where we write the atomic number. At the upper part, right, this left upper part, you have the mass number. In science, the upper part we call it the superscript, then the lower part we call it the subscript. So the atomic number, which is also known as the proton number, is written as the subscript, while the mass number is written as the superscript. So now, like we have here, mass number is written as the superscript. Superscript means top, while atomic number is written as the subscript. Subscript means bottom. Example, now look at hydrogen, an isotope of hydrogen. The proton number is 1, while the mass number is 2. Mass number to proton number 1. Can you see that is a 3 thing? Then the same thing for sodium, mass of 23, okay, written up. Then proton number of 11, written down. Then the next element is uranium. Uranium, the mass of 235, okay, and a proton of 92, as you can see. So this is how you represent the nucleus or an atom of an element in chemistry. Now, we have a question here which you want us to unravel. Now, the question says the element symbol for gold is Au. Okay, gold has a symbol of Au from the Greek word aurum, Latin name. Okay, so how many proton, electron, and neutron are found in the gold atom? So the gold atom is represented as Au. The atomic number is 79 and the mass is 197. So we are asked to calculate the proton, the neutron, and the electron. So now, how do we get the proton? So the proton number, which is the same as the mass number, will be equal. The proton number, which is the same as the atomic number, is 97. Okay, so how do we get the neutron number? Okay, so don't forget here we said the neutron number will be equal to the mass number minus the proton number. Neutron number is equal to mass number minus proton number. Always remember that. So when you remember that, and you can quickly get the proton number of gold. So the neutron number of gold. So that would be the mass number minus the proton number. So the mass number is 197 minus the neutron number is 70
was to 118. So the neutron is equal to 118. So why electron will be equal to 79, the same as the proton number. Okay, that is the electron number. Now there is another question here which says the radioactive element uranium has two common isotopes. We have uranium 236 92 and uranium 238 92. So the proton numbers are 92. The mass of this is 236, while the mass of this is 238. So we are asked to complete the table. Okay, so we have to complete the table. To complete the table, the proton number for uranium for the first one is 92. Okay, so therefore the electron number will also be 92. So how do we get the neutron number? So the neutron number is going to be the mass number, which is 236 minus 92, and that is 144. That is the neutron number for uranium 236. Now for the second one, it has the same proton, then the same electron, which is also 92, and the mass the neutron number, which is the mass number minus the proton number, that is 238 now, which is the mass, minus 92, which is 146. Okay, so the table has been completed, and that is the concept that has to do with mass number and atomic number.